Hello, this is Questionable Coding with Vladimir, and we're discussing most essential or well-known algorithms and problems that will be very useful to know for your next interview. And one of those problems is valid parentheses. So it's a problem that is not super hard, but still requires some idea of how to match parentheses. We'll discuss it in details. We'll see how many variations are there, and we'll try to solve most common variations of the problem. So let's see which parentheses are valid and which are not valid. And instead of parentheses, we will use the word brackets. It's a different word. It means something else. It's a bit different from parentheses, but for our case, I think it will be even better because it will describe multiple types of brackets, figure brackets, square brackets, and so on. So first of all, the basic example, it's the smallest correct example, maybe except an empty one, which we can't consider also a correct one. And this is about opening and closing brackets, just two of them. Not valid example in comparison is just two opening brackets, so we need to close them. Valid example with multiple levels. We see brackets inside of brackets inside of brackets. So we have three opening and three closing brackets. And not valid example, same amount of brackets, closing and opening, but in the wrong order. So we start with closing and then we continue with opening, which is obviously wrong. And it tells us that we can't just count them and compare a number of opening and closing brackets. Order matters a lot in such tasks, so it's not that simple. Also valid example, which is basically a combination of what we saw before, a couple of valid brackets inside of bigger brackets and just a separate small brackets on the right. And not valid example, and this one is interesting because it's very hard to see where is it wrong and on which step we can consider it wrong. We see that we have three opening brackets and then we close two and then we open one. Can we consider that as a bad case already, or we need something else? In fact, yeah, we need to cover the entire string of brackets to realize that we need an additional closing brackets here, as far as I see at least. So let's try to find the smallest bracket. We can remove it, another smallest bracket, another one, yeah, and we don't have a pair for the last one. So this is one of the ways to solve it, but usually in algorithm we'll use a bit different approach, and let's see which one. But before that, we'll check variations. So this task, it can differ from time to time, and one variation is having additional symbols. So here you can see spaces, you can see some variables like a, some operations like plus, minus, multiplication, and it's quite simple because we usually just ignore them. We check if it's a bracket of some sort, and we just forget about everything else. Usually we are not asked to validate if the operation itself is correct, so it will be a different task for us. So if we have additional symbols, usually we just ignore them and we concentrate on the brackets themselves. More interesting variation is multiple brackets types or parentheses types. So in this case, you see three types of brackets. It's like standard ones and square brackets and figure brackets. And they match with the same type only. So instead of controlling only opening and closing brackets, we also need to consider the type and once again the order. So it's a harder task and we will try to solve it a bit later. So let's go in our algorithm step by step, as we will do in code. And I have an example. It's pretty complex. It has three types of brackets, and I also copied it and color coded it. Maybe it will help a little bit to see what types of brackets we have there. So what is the algorithm? We go from left to right, and for every element we first decide if it's an opening bracket or not. If it's an opening, then we move it to the stack. It doesn't depend on the type, so we found another one, we move it to the stack, we found another one, we move it to the stack. And then we found a closing bracket, and now we need to work to understand, to do some work to understand if it had the pair before. So we take it and we start working with it. We pop a stack element, so the latest element we added to the stack, and if it has the same type, we remove both. So we found the pair. And with brackets, if you want to close something, you want to close the latest element you opened. It's like first in, first out. We found another closing bracket, and we also need to understand if it has a pair in the stack. So we pop the latest element in the stack, and yeah, it's the same type, so we can remove them and continue. Now we found another type of closing bracket. I'm not moving to the stack, that was a mistake. So I'm trying to find out if we already opened it, and I pop the latest element from the stack, and it's the last element. If we wouldn't have anything in the stack, but we would find a closing bracket, then we just end the execution because we can't close anything. There is nothing opened at that moment. But in our case, that's fine. We have an opening and a closing bracket of the same type. We remove them. Now we have an empty stack, and we found another opening bracket, and we move it to the stack. Then we found another one, also opening, move it to the stack, and the closing one. So we need to understand if we already opened it in the stack as the latest element, and yes, we did. So we'll remove them. We'll continue with our string or array, and we found another opening bracket. We do the same. Now it's a closing bracket. We take it from the stack. We found the pair, that's fine. And the last element, we are also moving it and working with it. We take the element from the stack, and that's a pair. And now we ran out of elements, and we need to check if the stack is empty. Because if we still have some opening brackets in the stack, it means we didn't find the closing one, the closing pair for them. So the stack is empty, so everything is fine. Let's move to another example. It's a simpler example, and we'll go fast. So once again, we have an opening bracket, we move it to the stack, another one, the fourth one, and then we found the closing bracket. We pop an element from the stack, and it's a pair of the same type. Another closing bracket. We move the latest element from the stack, and it's also a pair. Good. And now we have an opening bracket. Oh, that's fine. And we have another one, but it's a closing bracket. We pop the latest element from the stack, and it's a pair. And now we have a closing bracket, and we pop the element from the stack, and that's a problem because that's a different different bracket. And even if we would have an opening bracket somewhere in the stack, the latest element is not the figure bracket. So it's an error, and these brackets are invalid. So let's implement the algorithm. We have a task on Leetcode, and it has a function is valid, which receives a string which has three types of brackets: normal brackets, square brackets, and figure brackets. And we need to understand if it's a valid set of brackets. So first of all, we'll create the stack, and next we'll create a map of pairs. So we need to understand which brackets pair with which brackets. So we have a map, and we know that a normal bracket matches with closing normal bracket, and so on and so on. There are multiple ways of doing that. We can get rid of the map and just code it like if, then, but I think the map is stylistically much better because it's readable and it's very easy to add new pairs if we need some. Okay, so we have stack, we have map, and now we'll iterate through all the values in our string. I use a simple for loop for that. And for each element, we'll create a variable that we will reuse the same variable that has the current element, just to better track it and get rid of additional brackets in our implementation. So now we check if it's an opening bracket or not. So we say that if it's in our map, if it's a key of our map, then it's an opening bracket. In that case, we'll just add it to the stack. This check, it happens all the time, so for every element, but we have a limited number of elements in the map, so regarding complexity, it won't increase our complexity, because that's a constant number of three checks, and it can be more, but still it will be a constant. Okay, for another case, if it's not an opening bracket, then it's definitely a closing bracket because we don't have any other symbols in place. So what do we do for the closing bracket? First of all, we can check if our stack is empty already. Let's do it. It's not like required here, but I'll explain the difference. So if stack length equals 0, then we'll return false, then we have a closing bracket but nothing in stack, which is obviously wrong. Otherwise, we'll take the current stack element, or let's say top opening bracket. It's a long name, we can get rid of it entirely, but let's keep it for now. So it will be stack pop. Stack pop. And so we have a map of keys with keys which are opening brackets and closing brackets as their values. How can we compare it to the closing bracket, the current one that we have here? So I think we can have a pair for our top opening bracket. Let's call it closing bracket, which will be our map with the key top opening bracket. So basically we're taking our latest open bracket and we ask what should be the closing bracket for our last opening bracket. And now we know it's a closing bracket, and now we compare it to our current bracket, which we know that it's a closing bracket. So it's not super, it doesn't sound super clear, but I hope you get it. So we have our closing bracket that we just calculated, what we expect, or let's call it expected closing bracket. I don't like such big variable names, but at least it tells us what, it's more readable. So expected closing bracket, if it doesn't equal our current bracket, then it's wrong. Otherwise, we just continue. So we basically accept it as a valid pair and we continue. In the end, we need to return, not true, but we need to return that stack is empty. Otherwise, there may be opening brackets that we didn't match. So let's say we have 5 opening brackets and no closing brackets, then we just go straight to the end and it will be return stack length equals 0. That's our requirement for a valid case. Okay, what's the complexity of this solution? So first of all, what's the time complexity? Time complexity, what do we need to do? We need to go through all the elements of the array and to do some basic operations with them. So it will be big O of n, where n is a number of symbols in the string or number of brackets that we have. Okay, for space, in the worst case, we'll keep all the elements in our stack. For example, it's like n opening brackets, so it will be also on. Okay, that's fine. Now let's consider a simpler task, and maybe we'll be able to improve space or time. In fact, it will be space. So how are we going to do that? First of all, the task itself will consist of only one type of brackets, normal brackets. And we'll get rid of the map because we don't need any pairs anymore. We'll get rid of all the code here, and we won't use the stack anymore. And that's the most important change here. So instead of that, we'll use a parameter called opening brackets count, or opening count, let's say. Let's use the full name, brackets count. It will be 0 from the very beginning, and then we'll iterate through all the symbols. And what we're gonna do, we're gonna compare the symbols directly. So if current equals our opening bracket, then we'll just increase the opening bracket count. Else, we can check, or we must check, if opening brackets count equals 0. If it is, then we'll return false, and we cannot do anything here. We don't have a pair for the closing bracket. Nothing was opened by that moment. And if everything went well here, we just decrement the opening bracket count. There's a duck outside. So let's return the opening brackets count here, and we need to define that it equals 0. Okay, let's run our code with some example, some custom example. And it works as expected. So basically, we improved the space, and now it's constant space. So it's big O of 1, which is much better than linear space. That's it. Thank you for watching. See you next time.